compound from chapter 1. Chapter 1, number 10 here. How does a heterogeneous mixture differ from a homogeneous mixture, and how are they similar? All right, mixtures. What are mixtures?
You mean like water?
Well, water. That's a good question. Is water a mixture? Like H2O, is that a mixture?
It has hydrogen and oxygen.
Okay, but that's not what our definition of a mixture is. All right. Water is what we call a pure substance because in a container of water, for example, all of the water molecules have exactly the same combination of atoms, all right? Exactly the same structure. So when that's the case, we call it a pure substance, all right? Another example of a pure substance is something like just a big chunk of gold, right? That's elemental, because it's an element, all right? So pure substances can be something that is combinations of atoms, but all the same thing, and elements are pure substances. But mixtures, what are mixtures?
Oh, I remember now. Mixtures are different, either elements or compounds together in the same container, right? Same situation?
That's right. In the same container, all right? So if I have here some gold and some water, I call this a mixture, all right? So those are our mixtures. Now, another example of a mixture is something like water with sodium chloride in it, all right? Salt water. You've seen salt water before.
Yeah, I've seen salt water. I cook and I've been to the ocean.
All right, good. So salt water, the salt and the water are evenly distributed throughout. All right. If I were to look and see how much salt and how much water is in that little space right there, and compare it to how much salt and how much water is in that space, their concentrations, or the amount of each of the different components in the mixture, would be the same. And that's where the same part of homogeneous mixture comes from. This mixture here, which has some gold and water in it, here it's almost all water. Down here it's almost all gold. So this is different in terms of the components concentration, or the amounts in those different parts. So that's a heterogeneous mixture, and that's a homogeneous mixture. Okay, so how does number 11, how does a homogeneous mixture differ from a pure substance? How does a homogeneous mixture differ from a pure substance?
Homogeneous mixture are the two different things, but a pure substance just one thing.
That's right. Pure substance is just one thing. So my pure substance is here. This is pure water. That's gold. Those are pure. This is a mixture of pure substances, right? This is also a mixture of pure substances, but it's a heterogeneous, and this is a homogeneous mixture. Okay, 12. How does an element differ from a compound?
Gold's an element, right?
That's right. And water is a compound. Good. A compound is a combination of different elements coming together to form new structures. Okay? So, water, a compound, gold, an element, but they're both what?
Pure substances?
That's right. They're both pure substances. Okay. Good. How do molecules of elements and molecules of compounds differ?
Molecules of elements, what does that mean?
All right, so remember there were a handful of elements that are molecular in nature. Now, molecular means that they go around in multiple atom groups. So, for example, chlorine gas, Cl2, that's how you find it naturally. You never will find chlorine atoms all by themselves, all right? You'll find chlorine atoms combined with other compounds. There's a chlorine atom in this compound. You can find it like this, where this is a chlorine. Now it's chlorine ion because this is an ionic compound. All right? But chlorine atoms you'll never find by themselves. You'll always find them in pairs. And so that way we say that this diatomic element is molecular in nature. And that is the case for hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. All right. Let me bring up my periodic table, double check, make sure I'm not missing any. All right, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Good. And hydrogen. Yeah. So these are gaseous in nature. They are noble gases, but notice they are not molecular in nature. Okay. So number 14, how do atoms differ from molecules? Atoms differ from molecules. Well, atoms, like chlorine atom, it's different from a molecule because it's by itself. Here, that atom of chlorine is combined in different kinds of compounds, and we call molecules compounds that contain, this is an example of a molecular compound. This is a molecule. This is an ionic compound, so it is not a molecular compound. It's not a molecule, but an ionic compound is atoms that came together to form ions, whereas a molecular compound is an atom or atoms that came together to form ions. These ones are sharing electrons, molecular. Another name for molecular is covalent. Covalent. All right, very good. Okay, so now we're going to classify each of these as either an element, compound, or mixture. Okay? What do you think? Copper, is that an element, compound, or mixture?
I think it's an element, but how do I know for sure?
Well, if it's an element, we're going to be able to find it on our periodic table, right? And there it is. Number 29 is an element. Good. Okay, water, what do you think?
We just talked about that. Water is a molecule.
Water is a molecule. A compound. It is a molecule, that's right. It's a molecular compound. Now, how do we tell if a compound is molecular or not?
If it's molecular, it's made of nonmetals.
That's right. And hydrogen and oxygen are both nonmetals. We can look on our periodic table here. Hydrogen is a nonmetal, and here's our green staircase that separates them. Oxygen is a nonmetal as well. Okay, so compounds made of nonmetals are molecules or molecular. All right, so that is a compound. It's a combination of elements to form a new species. All right, what about nitrogen?
That's an element.
Very good. Now, here's another question. Is nitrogen, is that a nitrogen atom?
Sure.
Now, what is this thing? Why do we see nitrogen like that?
Well, I can't remember.
This is how you find nitrogen in nature. It's always diatomic in form. So it's what we call molecular nitrogen. All right. It looks like a nitrogen with a triple bond to another nitrogen. All right. And they go around in pairs like that. So this is how nitrogen is found in nature, but it is an element. How about sulfur?
Sulfur's an element.
That's right. Good. Air.
Air. Air is like, there's other stuff in air. There's oxygen in air and carbon dioxide.
Very good. There's oxygen in air. So air has, what do we call that then? What were our choices up here?
That's got to be a mixture.
That's right. It's got to be a mixture. Air is a mixture. Now, let's think. What's the main component in air? Do you know?
It's oxygen.
No, that's the second most abundant component in air. What's the first most?
Carbon dioxide?
No, it's nitrogen. Nitrogen gas is about 80% abundant in air. Oxygen is about 20%, 19 point something in air. And then you have your carbon dioxide, argon, and other trace amounts of other gases. Okay? So air is a what? A compound, a mixture, or an element?
It's a mixture.
That's right, it's a mixture. All right, very good. So, sucrose.
I don't know what sucrose is.
Well, we can look it up on Google and find out that sucrose has a chemical formula. Here, let's do that really quick. Chemical formula for sucrose. C12, H22, O11.
Oh, then that's a compound.
That's right. Is this a molecular compound or an ionic compound?
Can I see the periodic table?
Okay, so what you're going to look for on the periodic table?
Whether they're metals or nonmetals. Hydrogen is a nonmetal, and oxygen I know. Carbon.
Here's carbon over here.
Oh, it's a nonmetal also.
Good. So is sucrose ionic compound or a molecular compound?
It's a compound and it's molecular.
Very good. Molecular compound. Excellent. A substance composed of molecules, each of which contains 2 iodine atoms. What do you think about that?
Substance composed of molecules, each of which contains 2 iodine atoms. Well, if it's molecules and they contain iodine, is it a compound?
Sure, it's a compound. But this might be referring to a substance composed of molecules, each of which contains 2 iodine atoms. Kind of a weirdly worded problem, so we're not going to spend more time on it. But it could be referring to that, right? And that is elemental iodine. So, okay, if it means exclusively only 2 iodine atoms, if it means like this kind of compound here, CHI2, each of these molecules contains 2 iodine atoms. It's not exclusively 2 iodine atoms, but it contains 2 iodine atoms. Then this would be molecular compound. This is elemental, but it's molecular in nature. So it's kind of a difficult question. Confusing. Gasoline. What do you think?
What's gasoline made of?
That's a good question. We can ask Google here. Chemical formula for gasoline.
According to the Mad Scientist Network, so, to sum up, gasoline is a complicated mixture of hydrocarbons boiling between 120
Says
and
it's a
400
mixture.
degrees Fahrenheit.
Yeah, you caught that, didn't you?
Between hexacarbon tetradecahydride and C12H26, but
So-
a good average compound is C8H18.
So it's a combination, right? It's a combination of compounds that have this chemical formula or this chemical formula or a bunch of them in between, with an average being C8H18. And that's why you often refer to gasoline as containing octane. Octane. That oct in octane refers to 8, and the chemical formula is C8H18. So gasoline is a what?
It must be a mixture.
Very good. Gasoline is a mixture. Okay. Element, compound, or mixture. We're still going here. Iron.
That's an element.
Good. Oxygen.
That's an element.
Mercury oxide.
Got mercury and oxygen, so that's a compound.
Very good. Pancake syrup.
That's an element.
What?
No, I'm just kidding. Must have sugar and water, so it's got to be a mixture, right?
Yeah. Pancake syrup, sugar, water, vanilla, food coloring, maple flavoring, maybe some other salts, right? So definitely. Now remember what a salt is? Do you remember what the term salt means?
But what is salt?
Salt is any ionic compound, and we haven't talked a lot about that yet, but we will going further. And an ionic compound is a compound that is made of ions and often contains a metal and a nonmetal. Okay? All right, so could contain salts. How about carbon dioxide?
CO2, right?
Very good, CO2. And from that, we can tell that it's a what?
It's a compound.
Very good. And we can also tell that it's a pure substance, right? Good. Okay, so here's a substance composed of molecules, each which contains 1 hydrogen atom and 1 chlorine atom.
Well, this is not an element then.
Very good. Not an element. And I don't know if it's saying exclusively 1 hydrogen and 1 chlorine, HCl, or if it's, again, referring to something like this that has other atoms, kinds of atoms in there. Either way, this is going to be a compound, right? It's not going to be a mixture. It's going to be a compound. All right, baking soda.
What's the chemical formula for baking soda?
That's a question for Google. Do you want to ask it?
What's the chemical formula for baking soda?
The
Oh,
formula
good.
for baking soda
Nice.
is sodium hydrogen carbonate.
Nice, discrete chemical formula there. Good.